So you have some other problems where you have to find global maxes and mins that are pretty difficult. It'll give you an F that looks something like this. And now when it asks you to find the global max and mins, the first thing you have to do is find the local. And that's where all the difficulty is. Finding global maxes and mins, all you do is find the local, and then you also check the endpoints. And so here, with the local maximum and minimums, we'll start by taking f prime, and we'll see that we get negative 4x cubed plus 18 times 2, so 36x, and then minus 0. And we want to find when f prime of x, to find local max and mins, we want to find when f prime of x is equal to 0. And now these types of problems, they're almost always going to involve factoring. So let's see, what's the biggest common term we can pull out of each of these two things? Well, if I'm really greedy, I can pull out a 4x out of each of these terms. And here, this first term, I'll be left with negative x squared. 4x times negative x squared gives me this. Over here, I'll just be left with 9. Okay? And guys, so here's the reason that you factor. So at this point, I know that either my 4x needs to be equal to 0, or that negative x squared plus 9 needs to be equal to 0. When I have two things that are multiplied that are equal to 0, I know one of those two things needs to be equal to 0. So at this point, I know that if I plug in x equals 0, I'll get 0 here, I'd get 9 here. X equals 0 works, right? 0 times 9 is 0. I also need to figure out what I can plug into this part to make it equal to 0. And so if negative x squared plus 9 is equal to 0, I know x squared is equal to 9. And so x is going to be equal to positive or negative 3. So I kind of have three things that work here. I have three critical points, right? I have 3 points that I plug into f prime, and I'll get 0 out. So now we need to figure out which of these is a local max and a local min. And my favorite method for these is the first derivative test. So I'd have negative 3, 0, and 3. Just use this number line, right? And I'm going to check something on each interval to see whether it's increasing, decreasing, or increasing or decreasing, right? So let's check something to the left of negative 3. What are we going to get? So we'll get 4 times negative 4. And then if I plug in negative 4 here, I'll get negative 16 plus 9. And so this boils down to, it doesn't actually matter what this number is. I have a positive times a negative times a negative. And so this whole thing over here will be positive. What about a point between negative 3 and 0? Let's try something like negative 1. So 4 times negative 1. And then on the inside here, I'll have negative 1 squared plus 9. And so again, it doesn't matter what the actual numbers are. I'll have a positive times a negative times a negative, not a positive. Or no, sorry, times a positive. Negative 1 plus 9 is 8. And so this whole thing here will be negative. Again, so let's just check another interval. So let's try plugging in 1. So 4 times 1 times negative 1 squared plus 9. And I will get here again, I will get a positive times a positive times a positive. Here I'll get positive. If I go all the way out to 4, or anything past 3, sorry, let me erase some of this because it's getting in the way. So we try something at 4, so we'd have 4 times 4 times negative 4 squared plus 9. So I'd get positive times a positive times a negative. And out here I would have a negative. And so if I want to identify which of these is a local min and which is a local max, I have to remember that, kind of a hint up here, positive to negative. Remember that's increasing to decreasing, so that'll give me a max. If I go negative to positive, that's decreasing to increasing, so that's a min. So I have 3 critical points. I have 0, negative 3. Well, let's list it in the correct order. So I have negative 3, 0, and positive 3. And negative 3 goes positive to negative, so that's a max. 0 goes negative to positive, so that's a min. and 3 goes positive to negative, so that is a max. So, big summary, finding the local maximums and minimums. You want to find the first derivative, set it equal to 0, find the 0 points, and then use this number line to kind of determine if the derivative is positive or negative in between each of these zeros. And then, from those sign changes, you can determine using this rule if each of those things is a maximum or a minimum.